Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. This is our final project video presentation for AED0613 Semester 2, Session 2020-2021. I am Nur Jannah Najihah and these are my group members, Nik Nur Ain Fatiha, Mursyidah and Ahmad Yazid. In this video, we will be talking about two case studies, which are inconsistency of stairs height in CFS IIUM Gambang and the comparison of ramps in SMKA Tunas. Both studies will be including introduction, objectives of the study, problem statement, procedure and findings, and last but not least, the conclusion. I will start with the first case study, which is the inconsistency height of stairs in CFS IIUM Gambang. As for the introduction, we started off with the definition of stairway. A stairway is a construction designed to bridge a large vertical distance by dividing it into smaller vertical distance called steps. Each step is composed of tread and riser. As you can see, the image shows the components that build a stairway. That consists of tread and riser. So the tread is the one we step on and the riser is the height of the tread. The objectives of study are to find out the best method of measurement in order to achieve the consistency riser height. Second is to calculate the suitable height of stairs in order to allow students to feel comfortable to step on. And last is to redesign the structure of stairs by adhering to the standard guideline. The problem statements are the uneven consistency of the riser of each step, students do not feel safe when using the stairs, and the distance between the riser and the tread is quite excessive. That makes it a big mistake. Alright, so the procedures and findings. Firstly is to identify the standard measurements of a stair. As you can see, the picture shows the minimum tread width, which is 56 centimeter, the minimum tread depth, which is 24 centimeters, and maximum riser height, which is also 24 centimeters. Secondly, we chose one stairs located in CFS that has an inconsistency height of risers and treads. The stairs we chose are from Arjujani because the inconsistency height of risers are quite obvious. And then we measured the height of riser and the depth of tread for the stairs of Arjujani and take the average measurement of the stairs. So we took the average height of the riser because it has inconsistent height right of the riser. So we're going to have to take the average height. So after dividing it by 8, we get 9.75 centimeters for the average height of riser. As for the average depth of tread, we divided it by 8 and then we get 29.81 centimeters. Next up, we calculated the difference of both standard measurements and the measurements for the stairs of Al-Rujani. As for the height of riser, we subtract the 24 centimeters, which is a standard measurement, with the measurement of stairs for Al-Rujani, which is 9.75 centimeters for the height of riser, and we get 14.25 centimeters difference between the standard measurement and the measurement of the riser of the Al-Rujani stairs. As for the depth of tread, we subtract again 24 and 28.808 centimeters, and we get the difference of 4.808 centimeters between the standard and the measurement of the stairs. And those are quite big numbers actually. And then the fifth step is that we calculated the angle of the steps to identify the height of slope. What does this have to do with the objective? Okay, so when we know the height of slope, we know the amount of energy used for each person when using the stairs. Alright, so in this study, we can see that the law used here is the right-angled triangle law. So we use there's tangent, sinus, and cosinus. So the one we're using here is tangent because we have the opposite length and the adjacent length. So we can straight away calculate. So Tangent theta, tan theta is equals to opposite divided by adjacent, and then the opposite is 78 centimeters and the adjacent is 238.48 centimeters, and then we will get 18.11 degrees for the height of slope. Okay. In conclusion, so from the calculations, it can be seen that there is a huge difference between the measurements of the stairs and the standard measurements, and this is not a good thing, okay? The angle of the steps of our Jurjani stairs shows that it has a high slope. What does this have to do again? It causes more energy to be used by the students and other users, because the higher the slope, the more tiresome it is for people when walking through the stairs. So architects need to take this thing very seriously, because it affects people's lives and their health as well. So they have to be more careful when designing things like this.
Case study 2, comparison of ramps in SMKA Tunas. Introduction. An inclined plane is a flat supporting face tilted at an angle with one end higher than the other. It is used as an aid for raising or lowering a load, are widely used to move heavy loads over vertical obstacles. In SMKA Tunas, there is a brilliant and proactive student who cannot walk normally as other people, and he uses his wheelchair to move around. Caterers that prepares food for the dormitory students and require trolleys to deliver foods. The demand of concluded for the school to have ramp. Objective of study. Number 1. To find out the most effective design for an excellent ramp. Number 2. To help incapables undergo their days independently. And number 3. To compare and find out better angle between ramps. Problem statement. Number 1. Which ramp is more suitable for the purpose of aiding the incapable and for daily routine purposes? Number 2. What is the most suitable design for ramps? Procedure and findings. Number 1. Identify standard measurement of a ramp. Maximum ramp height and incline angle. Number 2. Choose two ramps with different measurements so that the both of it can be compared. The chosen ramps are as below. There is a picture of ramp number 1 and ramp number 2. Number 3. Measure of the length of both ramps. Ramp number 1. Height of ramp is 60 cm. Length of ramp is 747.6 cm. Length of running slope is 750 cm. The ramp number 2, the height of ramp is 36 cm. Length of ramp is 188.59 cm. Length of running slope is 192 cm.
After doing some research, we know that the additional features befitting for the ramps are handrails that needed as a support system, and treads to ensure safety of users and to avoid users from slipping. Measure the existing angle of both ramps. Firstly, tan x equal to opposite over adjacent, and then the value of opposite is 60 and the adjacent is 747.6. We divide and then press shift tan, insert the answer, then we get the final answer of 4.58 degrees. For the second ramp, same method, tan x equal to opposite over adjacent. The opposite is 36 and adjacent is 188.59. Divide press shift done, insert the answer, and then we get the final answer of 10.8 degrees. Next, measure the ratio of the running slope for both ramps. Okay. 60 cm divided by 2.54 cm, we get 23.6 inches. 750 cm divided by 2.54 cm, we get 295.27 inches. 295 inches divided by 23.6 inches, we get 12.5, and then we round off, we get the ratio of 1 to 13. For the next ramp, 36 cm divided by 2.54 cm, we get 14.17 inches. 192 cm divided by 2.54, we get 75.59 inches, and then 75.59 inches divided by 14.17 inches, we get 5.33. Round off, and then we get 5, so the ratio is 1 to 5. Procedures and findings. The most common placement is at the top of the ramp in front of the building entrance. Handrails are important features of a well-built ramp system as they serve as a safety device. It is important to have a safe walking surface on your wheelchair ramp. The ideal design for the ramp in SMKA Tunas. As SMKA Tunas has pupils who uses wheelchair and workers that need to use trolleys, so we choose to follow the guideline of commercial occupied use.